Hello! Hello, everybody. Welcome to the LIUniverse. It is such a pleasure to have you all with us today. I'm Dr. Charles Liu, your host, and as always, it fills me with happiness if you call me Chuck. Thank you so much for being here. What a great episode this is going to be. As always, let us begin by introducing our co host, Alan Liu. Hey, Alan.
Hello!
Hi. Investigated any recent space launches of
Oh
interest?
man, there's been so many recently. There's been, SpaceX had one, but one that I think has gotten a little bit underappreciated is ULA Vulcan had its second mission, and
Ooh,
one of its solid rocket boosters fell apart during the mission, but somehow it still made it to orbit safely, which just goes to show the power of
amazing.
that control software that it can handle to something like that.
Wow.
Yeah, I think that
I,
one might be relevant to today's conversation
I'm
for some reason.
extremely impressed. Yes, indeed. We have a tremendous guest today. Although we're leading with her work in space science, she's amazing in so many different ways, and it's such a pleasure to be able to be talking with Leah Voytovich. Hello, Leah.
Hi, thanks for
Hi.
having me.
Oh, it's such a pleasure to have you. Thank you so much. You come by way of amazing education at the University of Pennsylvania, and now you are on the West Coast. Tell us what basically you're doing right now, primarily. I know you do a zillion things. We'll talk about as many of them as we can in the episode, but what are you primarily doing right now?
Sure. So, right now, I'm working as a software engineer for Project Kuiper at Amazon, where I get to work on space lasers.
That is
Yes.
fun.
And tell us a little bit about Project Kuiper. We'll get more into it later, but tell us a little bit about
Sure.
that.
Yeah, so Project Kuiper is an initiative to launch a constellation of low Earth orbit satellites to provide internet access to the world.
That is cool.
Amazing. I think that's really, really awesome. You're not the only initiative along those lines, and that's probably a good thing. And there's lots of different things that are going on, and we will get to them as soon as we finish today's really cool, joyful cosmic thing.
Yeah, it's very close to correct this time. Or very close to consistent, I should say. Maybe,
Mhm.
maybe I'm a little too prescriptivist on this, but
That
a
is really
joyfully cool
okay.
cosmic thing.
The joyfully cool cosmic thing. Yeah, and it is really joyfully cool and cosmic because it has to do with a possibility of finding extraterrestrial life in a very creative way. Like, how do we even know if there exists an intelligent civilization that sort of has the
Mhm.
technology to do the things that we would like to be able to do, say, a few decades or a century from now?
Yeah.
Right? These are speculative things that we don't really know about. But there's this group that basically they're astrobiologists, but they're Earth and planetary scientists that are doing astrobiology. So I don't want to classify them or pigeonhole them in any group or any category only. But what they
Fair.
basically have done is they've imagined, you know what? If there were a civilization somewhere out there on an exoplanet that had harnessed nuclear fusion,
Hmm.
could we find out by looking at their atmospheric or their water compositions on their planets?
Hmm.
And the answer comes from deuterium.
Ah.
They came up with the idea and said basically, well, you see, if we are going to use nuclear fusion the way that we think we're supposed to, we're going to be using more deuterium, which is also known as heavy hydrogen, from
Yeah.
our oceans than regular hydrogen in proportion. And deuterium will be depleted from that planet's atmosphere or its oceans as a result.
All
So,
right.
from our distant view, they made a calculation and they said, you know what? By measuring whether or not they have lower deuterium abundance than the rest of the universe, we can deduce, perhaps not even during the time that they're on, but for centuries afterwards,
Hmm.
that there has been nuclear fusion being used as a power source by that civilization.
That's really cool.
I think
I'm
that's
yeah.
amazing.
I'm reminded of so our current nuclear power is nuclear fission. We've talked about this before in some
That's right.
previous episodes. But our nuclear fission byproducts, the nuclear waste and the isotopes that come out of that, um, those stick around for a really long time, and
They do.
you feel like there was this really crazy case where there was a natural nuclear fission reactor that happened like billions of years ago in Africa in like a
Amazing.
uranium deposit, and we can see that fission reaction was taking place because we can see its nuclear waste essentially is still there after
Wow.
billions of years. It's just safe now because it's been so long, but you can still find it.
That is truly remarkable. It brings up a larger question, right? Uh, if you're going to deplete any resource in our world, right, for the sake of technology for something or another, right, we have to be careful that there are unintended consequences do not outweigh or make worse than the things that we want to do originally, right? Nowhere is this more true than in space, I think, where we are uh, either setting ourselves up for stuff falling down on us and causing us problems, or right that we are going to make the next step in human society, going from being trapped on one planet to be able to go somewhere else, right? um, deuterium is especially interesting because it doesn't really ever go away once it's been created out in the universe. In fact, the elemental abundance of deuterium compared with regular hydrogen
Yeah.
has remained essentially unchanged since a few minutes after the Big Bang.
Yeah.
Right? It only changes temporarily inside the hearts of stars, for example, but that all equilibrates again within a few centuries or a few millennia or something like that. Now, here's the situation here on this planet where it could last for a really, really long time. Have you ever thought a little bit about that whole aspect of things? Because you, I know, we'll get to this explicitly not too long from now. But you've been thinking a lot about things like environmental issues and human impacts on them. And right now, what you're doing, with Kuiper and sending thousands of satellites up into space. I mean, that's some pretty amazing stuff, right?
Thanks. Yeah, and definitely one of the main goals of Project Kuiper is to be sustainable, and
Mhm.
so that is kind of one of our core pillars when we design any engineering product.
Wow.
Yeah. So what are some cool ways that that you've been doing that with Project Kuiper specifically? I'm just curious.
Yeah, so unfortunately, I don't think I'm allowed to talk about this just yet, uh,
Ah.
but I. But there is a very strong initiative to make sure that the way that we are engineering this service is as sustainable as possible.
That's really
Okay.
cool. We'll keep an eye out for that when it becomes public.
Yeah, that's very, very helpful. And for astronomers in particular, right? Leah, that we are all quite concerned because if you have too many satellites and they're too reflective, then all of our surveys of the dark sky will be streaked one picture after another with all these satellites coming through, sometimes even flares, right? Where you get the sun directly going down the telescope's throat, and that whole image gets lost because of that flare. Is that something that you are at all aware of what you guys are doing to prevent that sort of thing from happening?
Yes, so that is another thing that folks are working on. I personally am not working on that solution, but folks in the lab are trying to minimize impact to astronomy. Um, and unfortunately, I don't think I can say too much more about that just yet,
That's
but
fair.
I'm sure
That's
This is
that
fair.
will also be publicly available
this is
eventually.
going to be a seriously redacted episode. It'd be like
Yeah,
people
little
read the
black
transcript, we
bars.
have little black bars all across
It's like we're the
everything.
CIA or something, but it's fine. We
But
understand it needs to happen. Well,
yes, but
what is
it'd
it
be
that
fun.
you are doing? I heard you in the intro. You were talking about
Mhm.
software engineers and space lasers, both of which sound pretty cool.
Yeah, tell us, tell us, tell us.
Yeah, so I've gotten to work on a few exciting projects at Kuiper. When I first joined, I was working on a service that was responsible for allocating radio frequency beams between
Mm,
the satellites and the Earth.
Hmm.
And that is a fairly challenging problem because the satellites are low Earth orbits, so they're
yeah.
moving extremely quickly. And so we have to replan the assignments between the satellites and the ground stations that they're pointing to fairly frequently.
Okay.
And we also have to take into account a lot of other factors like customer demand and weather and regulatory restrictions and things like that. So it's a really challenging problem that requires a lot of fancy optimization techniques to solve.
Hmm.
So
Wow.
then I worked on that project for a little while, and then I ended up designing and developing my own service, which was used
Whoa.
to, yeah, it was, I'm still very grateful that they trusted me to do that. But this service was used to facilitate all of our in-orbit payload testing.
Oh, okay.
So around a year ago, we launched our first 2 satellites, and they were
Nice.
test satellites. And yeah, my service is the flight directors would interact with my service to, yeah, schedule different types of in-orbit payload tests. And I think
Wow.
that's as much as I can say. And now I work on the space laser stuff software for it. So I work on a service that's responsible, similar to the service that schedules those RF beams.
Hmm.
This service schedules the inter-satellite links or
Wow.
optical links, which is
Oh,
how the
okay.
satellites communicate with one another in space.
That's
Okay.
awesome.
So these space lasers are talking to they're aimed at each satellite. They're not like aimed down at the Earth or anything
No,
like
no,
that.
no.
Okay.
We are not shooting any space lasers. Yeah.
I remember that NASA did a thing with using LADI, which is a moon space probe that they were testing, and
Uh-huh.
they were using a laser to communicate by like pointing it at the Palomar telescope or something like that. I think it was Palomar, one of the
Wow.
telescopes on Earth, to like see if they could see that laser blink from the moon, and they got like really really fast data speeds with it because you can
Amazing.
just modulate that laser so much faster than you can a radio frequency. I imagine that this is related to that.
Yeah, so the cool thing about using light waves instead of the radio waves for
Hmm.
communication is one, as you mentioned, we can transfer so much more data within the same amount of time. So it's like a much, because the light wavelength is shorter,
Hmm.
so we can transfer more data more quickly. But also, it adds a lot of security because it's much more
Ooh.
difficult to
Oh,
intercept a laser than it is a radio frequency beam.
that
That
makes
makes
sense
sense.
because
Yeah.
the radio goes out like this and the laser goes straight.
Yeah.
Oh, wow.
And we add, so the satellites are moving very quickly. And so intercepting the laser between the satellites is extremely difficult.
Oh,
Okay.
wow. I
I,
love that. That's cool. Thank you for keeping my inter-satellite internet
yeah.
away from the prying eyes of those who would otherwise try to see what's going on.
I'm really curious now. So I don't know if this is a big enough factor for either of them, but I know that when we talk about in astronomy, we have redshift and blue shift, right? So when you're looking at light from a moving object, or like a radio wave from a moving object, that motion changes the frequency of light that you see, or the radio wave that you see. Um, are satellites fast enough to do that with radio frequencies, and are they fast enough to do that with light frequencies, like visible light frequencies, or is it not really relevant for either of them?
I don't think it's relevant. Also, I should specify the optical links are infrared, so they're not
Okay,
visible
so
to
they're
the
not
human
visible,
eye.
but
Yeah,
they are still lasers.
they are still lasers. We
Okay,
just have
cool.
to control them.
But remember, even if they were optical light lasers, unless there's like chalk dust between the satellites, you can't see the laser beam anyway, right? Because they're aimed sideways. If you're looking sideways at a coherent beam of light like a laser, you're not going to see it. You need something to scatter off of it and go to your eye. So infrared is still cool. Okay, just let's not mince
Yeah.
words. Infrared lasers in space. I love it. uh, let's go to a question. Do we have? I know we have some questions. Alan, why don't you pick one and let's go with this question.
Sure. I'm going to start with a question from Yasmin here, who is asking, will our satellites all be controlled by AI someday? If so, when? And is this a good idea?
Ooh, Leah.
Yeah, so I can only speculate, but I imagine there will definitely be some elements of machine learning
Mhm.
controlling our satellites. Maybe not entirely, but like I mentioned, like just even the task of assigning radio frequency beams between the satellite to ground is so complex and requires these very complicated optimization algorithms to solve. I imagine as these like satellite constellations get more and more intricate, using machine learning to solve problems like that will probably be a helpful idea.
So that would be
Ooh.
like using machine learning on the ground to like solve these problems, or using machine learning on a computer on board the satellite itself.
on the ground initially, most
Mhm.
likely.
That makes sense.
Maybe eventually there will be some ML thing running on a satellite, but that might be a little further into the future.
Yeah, how long in the future? Let's answer Yasmin's question there. How long do you think?
Hmm. I think I think that ML can be incorporated uh, on the ground to control satellites, like in the very near future. In fact, I do wonder if maybe some projects or companies already incorporate ML
Wow.
in their satellite projects. Running ML on the satellite, I don't know. Maybe a little bit further down the line.
And is it a good idea?
I think so. I think just using machine learning to solve complicated problems for our benefit. Yeah, I don't see a problem with that.
You don't.
Yeah.
Okay, so
I guess
you don't see any issues with our artificial intelligent overlords controlling our space stuff or anything like that. That's not something that bothers you.
I mean, we obviously have to have a lot of protections in place, and ultimately, like the software is controlled by humans, right? We're the ones still writing the software. We're just leveraging ML tools to to help solve our complicated problems.
yeah,
You've heard of Cyberdyne Corporation, right?
from the Terminator.
Dun 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 dun
Yeah.
dun.
Yeah, no. I feel like that's a reasonable way of looking at it. Like there are concerns about AI doing things beyond our control or things where we're not the ones in charge of what it's actually doing. I feel like that's probably not a bigger concern with satellites than with anything else. That should be about equally concerning as Earth-based computers. I should suppose.
I suppose. All right, let's take a short break and we'll be right back on the Luniverse with Leah Voytovich after this. Hey, and we're back here on the Luniverse with Leah Voytovich. How's it going out there? Now, by out there, I don't mean in outer space where you are working on your satellites, but like out where you are. What is it geographically?
Oh, it's so much fun. I live in Seattle,
Mhm.
and since moving to Seattle, I've become very outdoorsy. So in
Oh,
That's
the
cool.
winter, I do a lot of skiing, and in the summer, a lot of backpacking and hiking.
oh yeah. Do you do like extreme stuff? Like do you climb thousands of feet in an hour, or you run miles and miles and miles and things like that?
I guess extreme is a relative term, but for me, yeah, I climbed like Mount St. Helens, for example,
Wow,
which is a volcano in this area,
Yeah.
which I never thought I'd be able to do.
wow.
And I've backpacked a few times, which I also like. Before moving to Seattle, I had barely gone camping, let alone
Yeah.
backpacking.
Oh,
So to me, it feels extreme, but
That's
oh,
definitely fair.
it's plenty extreme. And and like endurance type stuff. You do anything fun like that recently?
yeah, I just ran my third marathon a
Oh,
couple weeks ago, but
really?
very slowly. Yes.
Oh, congratulations. Now that's amazing. I know
That's
that
pretty awesome.
there are people who have run marathons that put, the sticker on the back says 26.2, basically showing this is how many miles that have run. I myself am still looking in sporting goods stores for the sticker that more appropriately writes down how much I'm able to run, which is 0.262. So I figure if I get a quarter of a mile in, I
I
count.
bet you could go for 2 2/3 miles. I bet you could do that. One more factor of 10.
That's right. Well, listen, Mount St. Helens, as you know, blew its top about 40 years ago. I mean, just the entire top of the mountain is gone now.
Yeah.
What's it like today? Is it still active? Is it alive? Is it just a wasteland? What does it look like up there?
I think it's still technically active, but would need to confirm that. But what it looks like is I climbed it in the winter,
Wow.
and there are sort of three sections. And the first section felt like an ordinary hike, and it was below the tree lines. There were just a lot of trees in nature. The second section was sort of a boulder part, so there was just a lot of rocks,
Mm.
and that was really cool. And then the third section was all snow. So I was climbing with an ice axe and crampons, and
Oh,
Wow.
it was so foggy that I didn't see anything.
oh,
I saw
Oh
no
man,
views at all. But it was a really cool experience.
that does
that's
sound
pretty
super
cool.
cool. You didn't see like steam erupting out from like, vents in front of you, like in Princess Bride or anything like that. The ones that fry the
Unfortunately,
rodents of unusual size. Okay,
no.
it's just fun to think about those kinds of fun things. But that's amazing. I mean, it's just an earth science lesson in itself, right? Planetology and so forth, right? We've learned our first thing about exoplanets by studying our own. But I want to circle back to the idea that you uh, really primarily are a computer science person, right? And it's very clear in the conversation that we're having when you use like the term service, right? You know what that means, and I know what that means because I know a little bit of computer science, but not everybody does. Also, ML rolls off your tongue, right? And we all have to think of machine learning. And so when we say AI, you say ML because you know the difference, but we sometimes don't have a clue. We think, oh, if a machine can learn, then surely it is artificially intelligent, that kind of thing. Give us your take technically on that. What is the difference really between artificial intelligence and machine learning, and what kinds of safeguards would you think are valuable for us as we looking outward and we're using more and more equipment to sort of study the universe, but meanwhile on the ground we've got all this computer stuff floating around?
Yeah. So artificial intelligence is just an umbrella term for a lot of different things, and machine learning is one aspect of artificial intelligence that I'm more familiar with. And machine learning is essentially just feeding a machine a lot of data and
Yeah.
having that machine recognize patterns from that data and make predictions based on it.
Mhm.
Uh, yeah, and with regards to say like measures we can take to make sure that the ML techniques we're using are safe is we I guess it depends what type of machine learning you're using.
That makes sense.
Mhm.
Most of my experience has been with supervised machine learning, which is training tagged data. And I think it depends on the use case and the approach that you're using, but making sure that you do a lot of testing, I think is really important.
Well, I know that a few years ago you were using machine learning to try to study galaxy populations. So very much a astronomical application of that kind of tool. And of course, it has only developed since then, while other
For
things are
sure. Yeah.
going on. So I think, as I've said before on the show, that artificial intelligence as an umbrella thing, right? AI, ML, things like that.
Mhm.
Are a valuable tool, and astronomers certainly don't fear it because we've been developing it through our years. But there does come a point, right, where you're really leaving the realm of using it as a tool for science, and it's becoming a tool in our everyday lives. And
Right.
there's a fascinating sort of contradiction that you have in your life, whereas we kind of have a stereotypical idea that like if you're an artificial intelligence machine learning meister, an expert of awesomeness in this area, then you're basically indoors all day long. You sit in front of your computer, maybe you order pizza, maybe you order a lot of pizza, and you just stare at the screen and stuff like that. But that's not you at all. I mean, you're out there climbing mountains with crampons and ice picks and running marathons and stuff, right? I mean, how does that work? How does that sort of balance in your life and your thought processes?
So also, I actually don't work with ML right now in my
Uh-huh.
current job.
Okay.
I am a software engineer, and I do think that there is a bit of a stereotype when it comes to software engineers as
Yeah.
being introverts who kind of hole up in their rooms sometimes in front of their
Yeah.
computers.
Yeah.
But I find that's not always the case. Sometimes it can be, but definitely not always. And the people that I work with are so fascinating, and everyone has really exciting personal lives outside of work.
Mhm.
And I'm really lucky that my job allows me the work life balance to pursue other passions.
Mhm.
That's
One of
always
them,
good.
yeah, I think that's really important. Uh,
Yeah.
I also had another response to your ML question.
Oh, okay. Go for it.
Well, so have you all heard of the Chinese room argument?
Yes, I have, but
I
I
have
would like to hear
not.
it again because it's very cool.
Oh, neat. I
Yeah.
do not know this.
Okay, so imagine there's a man who speaks no Chinese and he's in a room with no windows. And in that room, he has access to a book that's completely written in Chinese and it has questions and their answers in that book.
Yeah.
Now, someone from outside of the room who has no visibility on of what is inside the room. So someone from outside the room slips the man a question in Chinese.
Yeah.
Now the man looks up the question in the book. He writes down the right answer and then slips the note outside
Yeah.
with
Wow.
the answer in Chinese back to the
Mhm.
person outside. Now, the question is, does the man in the room understand Chinese?
Whoa.
So yeah, one of the really this has been fun from a philosophy question type perspective. I don't know if you have your opinion on it, but I have my opinion on it. And I can say at some point too.
Yeah, sure. But so, Leah, what is the point of that fascinating thing? Which, by the way, reminds me very much of Schrodinger's cat. This is like, you know, unless you open the box, you don't know
Yeah.
whether the cat is alive or dead or some mixture thereof. In this case, it's like you unless you open the box, you don't know whether the person inside can actually speak the language.
Right. So we know that this man does not understand Chinese. Like we know that he's simply looking up the question in this book, writing down the answer, but he has absolutely no idea what the question or the answer means. But to the person outside of the room, it seems like this man speaks Chinese, right? Because every
Yeah.
time he asks a question, he gets the right answer. So I kind of view machine learning that way,
Hmm.
where maybe like if you're interacting with some chatbot or something, it can seem like the machine understands what's going on or the machine understands English, and but really, if you look under the hood, uh, it's just an algorithm.
Yeah, so that brings to mind a couple of things. One is there was one person who talked about AI as a stochastic parrot.
Stochastic parity?
Stochastic parrot, like a
Parrot.
bird, like the
Oh,
bird that responds to what you say. And so you say
oh,
something and it copies you. And the idea
yes.
is that it's stochastic was a mathy, sciencey term for adding randomness. So
I
it
see.
repeats what it's heard, but with some randomness added.
Okay.
So about there's some probability it'll choose each next word as opposed to it automatically repeats exactly what you told it.
Oh,
So that's a pretty cool analogy people have come up with, and people have argued to what extent it applies. And then the other thing with the Chinese room argument specifically that I've heard is sort of asking questions like maybe the man in the room doesn't understand Chinese, but whoever made that book in the first place had to have understood it.
Right.
So,
right.
so where
So,
did the book come from? So there is some understanding in there. It's just not in the system that you have in the room.
Right.
whoa. So does that mean that there is some artificial intelligence within the book, which was left there by a naturally intelligent author before the room was sealed?
Well, what I imagine the analogy to machine learning would be is that the people who wrote the text that the AI is training on have intelligence, and that the
Hmm.
AI might be sort of in some sense mirroring their intelligence, like our collective human intelligence, in
Wow.
the way that it comes up with responses.
Wow. Leah, does that sound like intelligence to you?
Yeah. It makes sense.
That's
I don't know.
amazing.
There's a lot of really cool ideas about
Well,
this kind of stuff. I
I
love it.
just think it's awesome because, yes, that we are getting so close to being able to understand intelligence, even though we actually don't understand the wetware that's actually in our skulls so much. Right?
Yeah,
That's really
I don't
quite
know how
remarkable.
close we are to understanding intelligence. I say we definitely are getting better at it, but I don't know we're
Uh,
close to finishing understanding it.
Leah, is your take on artificial systems like mechanical reasoning and machine learning? How close do you think that is to actual human learning or animal learning, or learning in that you and I are doing right now? Like I'm learning about stochastic parrots in the Chinese room. What's your
Yeah,
take on?
I think I think there's a lot of similarities between machine learning and human learning, because humans also learn from sensory input, right?
Hmm.
That's how
Yeah.
we obtain all of our information, and then we will make patterns and connections based on the input that we receive. So machine works in a similar way.
Mhm.
Makes
But
a
that
lot of
that
sense.
machine works in a similar way because we invented the machine, right?
Right.
I mean, we looked at our brains, or tried to understand our brains without opening them up. So our brains are in some sense a Chinese room to some extent, right?
Eh.
And then we're like saying, okay, what does this room input and output based on what we know? And then we're putting that into a machine and we're trying to have it do the same thing, right? I think that's amazing. I mean, obviously, there's a lot of linear algebra involved too.
There's a lot of linear algebra.
That's a different story.
A lot of matrices.
Yeah. Oh, not the Matrix.
Not The Matrix, the movie.
Numerous matrices.
But yeah, matrices with numbers in them.
I think that's
It's
fantastic.
very exciting.
Wow. Okay. This is a good time for another question, right, Alan?
Yeah, sure. This is a question that I feel reflects a lot of people's opinion on the ideas of things like space exploration and so forth.
Oh, okay.
And so this is a question from Jonathan, who's asking it this time specifically. And Jonathan asks, with so many problems facing the world like poverty, war, and the climate crisis here on Earth, why should we spend money and resources on space exploration and astronomy?
I think that's a really valid question. I will say at least Project Kuiper, as an example, aims to serve underserved communities.
Yeah.
So it aims to provide internet access to communities that currently don't have that. And I think that can help solve some of these larger global issues just by getting the world connected. So I think and to launch our satellites, we need rockets.
Yeah. I think that's one of the things we'll talk about, right? Like the idea that exploring space and learning about space is helping people here on Earth.
Mm-hmm.
Yeah,
well,
so
I think that's a very valid point. I obviously, as an astronomer, think that that's true. But I think Jonathan is making the point here that if we spend $1 today doing something in space, does that bring back only 20 cents on the dollar's worth of benefit here on Earth? Or does it bring back $10 benefit here on Earth? And is it an investment that's appropriate, right? I mean, Leah, you have a very interesting personal perspective about what it means to do things on Earth and in space. I mean, you're doing both of these things at the same time, right? So your insight here is valuable. Your point about helping underserved people get internet is in itself interesting, but there's more to it, right?
Yeah, I think I have in the past worked with an extremely rural community
Ooh.
that has no access to internet or I think having giving them the ability to connect would be so beneficial to that community just for the sake of learning. Like, for example,
Wait, tell us about this community.
Yeah.
Is this like in South Dakota or something like that?
No, so I have a nonprofit which works with a community of refugees in northern Uganda.
Whoa!
That's pretty cool.
Holy moly! Seriously?
Yeah.
Okay, this is a whole nother episode, but tell us about this. This is amazing. Wait, you're doing Kuiper, you're doing like satellites, you're doing machine learning, you're doing astro stuff, and you have a nonprofit working in Uganda?
Yes.
Holy moly! You have to tell us about this.
Sure. So the nonprofit is called Maji, which means water in Swahili. And the primary objective is to make clean water easily accessible to refugee communities through solar powered technology.
Ooh, okay.
So that is our primary objective. And then we have 2 secondary objectives. One is to provide first aid medical training to the communities that we work with. That is my sort of passion project because I am a former EMT of 3 years.
Oh, cool.
You're doing yet another thing? You've done yet another thing? Well, I mean, you have like had 10 things you've done and you're like barely out of high school. This is ridiculous. I'm so in awe right now. That is amazing. Okay, sorry. I'm interjecting when I should. I'm just too excited. This is out of control. Okay, tell us more.
So our secondary objectives are the first aid medical training and then providing agricultural training, which is my co-founder's expertise.
Okay.
We built a solar-powered water tank, which currently provides clean water to a community of 4,000 people. and I ran the in-person first aid medical training seminar for the community a few years back.
You
And
like went to Uganda.
I
I
did.
imagine this was not telemedicine.
No, so during my first year out of college, I was both working full time for Kuiper and for my nonprofit, and I used all of my PTO days from Amazon to go to Uganda and do all of the things I needed to do on site. But then
Wow.
the rest of the year, I was working stateside, obviously. But my co-founder was working full time from Uganda with our on the ground team there.
That's amazing. How did you get Maji started? I mean, what caused you to focus on a place like Uganda for that matter?
Yeah. So, okay, it started over a dinner that I had. So I was during my junior year of college, I went to my good friend's house for dinner,
Wow.
and there were a few friends there, and we were just chatting, having beer and chicken, as college students do. And
You weren't 21, were you?
I
Beer
was.
and chicken?
Hey,
Huh?
listen,
Huh?
we're not.
Okay, all right. We're not
That's not the point. That's
yeah.
not the point.
Okay.
Yes, yes. And my good friend's roommate, who I just met that evening, we ended up having a conversation about just our dreams for the future for after college and how important it was for us to work on something that would be impactful for the world. And by the end of that dinner, we decided to team up together to apply for this prize that my university was offering. So it's called the President's Engagement Prize.
Okay.
And the University of Pennsylvania offers this prize, which is like a grant for nonprofits, and only seniors at the university can apply for it.
Oh,
And it's a pretty sizable grant. It's $100,000 plus $50,000 per student involved in the project.
Okay.
wow.
So yeah, it's a really sizable and very competitive prize. So we didn't think we were going to win, but we decided, you know what, this is such an exceptional opportunity. We might as well apply and see what happens.
Mhm.
And so then we were brainstorming different nonprofit ideas. A lot of my ideas actually were EMS or first aid related
Mm.
because I was an EMT at the time and I was very passionate about that. But my co founder, Martin, he grew up in a refugee camp and he was very familiar with a lot of the experiences that folks in these types of refugee camps go through. And so he proposed bringing clean water to this community that he actually had a tie with.
Wow.
So
Mm.
I thought that was so impactful that if we were able to provide this entire community with clean water, of course we should chase that down. So
Yeah,
Wow.
for sure.
And obviously the president of University of Pennsylvania thought that this was a good idea because there you were providing water and first aid knowledge to thousands of refugees halfway around the world. That is super awesome. I think it's amazing. I'm not worthy. I bow down. I mean, that is so so cool. And to tie that analogy to Jonathan's question about the use of space exploration, right? The the solar technology, the solar panels that are working to purify the water probably had its technological origins in the space program when we needed spacecraft to be powered by the sun.
Yeah, I know that NASA was pioneering a particular kind of solar panel that uses a single silicon crystal that's like now like everywhere.
Yeah. Did you have that connection in mind too when you were doing this?
no, I didn't have that specific connection in mind, but that is a really good point. I think also just bringing connectivity to that community would do so much for them,
Mm.
particularly in the aspect of healthcare.
Hmm.
So I
Yeah.
met with the folks in the community who were kind of the equivalent of EMTs, but for that community,
Uh-huh.
and they unfortunately had very, very minimal training and knowledge of just healthcare in general. And
Wow.
they were, yeah, extremely kind people. I was so grateful to get to work with them and in my seminar. But yeah, like as an example, they believed that the heart and the lungs were one organ.
Oh my
So it
goodness.
just if we could just, yeah, for the sake of sharing knowledge, and for the sake of healthcare. And I think it would just do so much.
Wow. We're not even talking
Wow.
about like different surgical techniques. We're talking about where the
Very
organs are in the
basic.
human body.
Yeah.
That is amazing.
Dang.
It's a deep issue that we have such a difference in our understanding of our human bodies, the universe, the world, from place to place on our Earth. Wow. So you're kind of helping to level the playing field a little bit, right?
I hope
That's
so.
amazing. Wow.
That's
Uh,
really cool.
well, we are running out of time, but I just wanted to ask one last question for now because we've got to have you back because you have like 10,000 things going on. We got to have an episode for all of them, Leah. But the question I had was when the Kuiper satellites first launched,
Mm.
surely you were involved in the launch. And if so, I want to hear about that experience because, being involved in the space launch of anything, you know, but that would be awesome. But like a first of its kind satellite, that would be even cooler. Did, tell us what you did.
Yeah, that was a really cool experience for me. I was lucky to represent my team in the mission control room. So I was one of the people that said go or no go for our services.
That's awesome.
Um,
Wow.
the go or no go was not for the actual launch, I will admit. It was for payload related things. But I still was in the mission control room, which was so cool. And it was a very historic moment because it was the first ever Amazon satellites that were
That's
launched.
amazing.
And we had worked so hard on these just two satellites. And when they initially connected to our stations on the ground, it was such a joyful moment for everyone in the room. We were standing, we were clapping.
Oh,
It was so I feel so lucky to be a part of
That's
that
great.
experience.
that's just so cool. So you were there in the room when the mom, the mission uh, oversight person, basically says, "This service, go or no go," and you got to say,
I got to say go for my whole team, which is the software defined networking, or org, I would say. Yeah.
"That is
That's
so
awesome.
awesome." Is the room like the way it shows up in movies? I mean, is it that cool?
Kind of. Maybe not quite as cool as the movies, but to me, it felt really cool. We had a really large screen in the middle of the room, which was showing the launch. And then each representative in the mission control room had their own screens that they looked at, and everyone was looking at their own dashboards and monitoring their own services. And
That's amazing.
yeah.
Oh, this is so cool. And just to top it off for all of our young aspiring mission control people who want to be involved in space, uh, you've been so humble about this, but this is true. You didn't think that you would be, involved in the satellite stuff. You didn't think that you would be doing space. You wouldn't think you would be doing pioneering stuff. You just were doing what medical stuff, being an EMT or playing with computers because they're fun. And here you are, just because you kept doing stuff and because you enjoyed beer and chicken with friends and just kept pursuing things, you have done amazing things.
Yeah, I will say I'm very lucky because I do have quite a lot of passions, and I don't have a clear sort of path uh, for my career that I'm sort of looking at. I think accept, I chase down opportunities that excite me.
Hmm.
But the way I got into Kuiper was actually totally by accident. So yeah, in college I was pre med. I was working as an EMT, but I was also studying computer science, applied math, and cog sci because mainly computer science because I was just really fascinated by it, and I had so much fun working on really challenging projects and suffering with my fellow peers. But then yeah, my plan was to go to med school. Then I started the nonprofit, and then my plan was to just work full time for the nonprofit the year after graduation, sort of take a gap year, and then apply to med school. But in my senior year, Amazon recruited me for this opportunity,
That's
and
awesome.
it was just so cool. I could not say no, especially because when I joined, we were like really in the initial stages of designing this project, and the fact that I got to be part of that was so cool. So
Yeah.
that's how I ended up here.
Wow.
And
And
I've loved it, so I've stayed for several years now.
now it's wonderful. And you got to say go.
I did go.
That is amazing. Uh, we will talk again. Okay, Leah, we will have you back because you have so much more to tell us when you're finally allowed to tell us some of those things. But beyond that, there's just so much to discuss, and I can't wait to find out how that all works, how that community you're helping is impacted by the things that you do, both on the space science side and on the ground science side. Leah Voytovich, thank you so much for being here. Thank you so much for being a guest with us today. It's such a pleasure.
Thank you so much for having me.
Alan Liu, our co host, as always, thank you so much for everything that you've done and made this show awesome, as always. Thank you.
You are welcome, as always.
And to all of you out there in the audience, thank you for being with us on this journey in this episode today. If you've liked what you see and hear, please support us on Patreon, where you can find cool stuff that we have just run out of time to talk about here. So, thank you all. And as always, thank you for being a part of the LIUniverse.